In this lesson, we're going to look at all types of trees as related to graph theory. A tree is a connected graph that contains no cycles, no multiple edges, or loops. A tree can be part of a larger graph. Graph 1 is an example of a tree, so is graph 2. But we can see that graph 3 is not a tree. Here there is a cycle, here there is a loop, and here is a multiple edge. There is a rule that connects the number of edges of a graph to the number of vertices. So for a tree with n vertices, it has one less edge, n minus 1. Every connected graph contains one or more trees. Here we can see a tree in red and a tree in green. A spanning tree is a tree that connects all the vertices in a connected graph. The example shows one spanning tree in red. Others are possible. In this example, we want to find at least two spanning trees for this network. Okay, for this network, here's one possible spanning tree. Here is another spanning tree. A minimum spanning tree is one that minimizes the total of the weights in a network. There may be more than one in a weighted graph. Minimum spanning trees are applied to problems where you want to minimize things like materials, costs, distances, times, or other quantities in a network. Examples include minimize the cable lengths in a network of a computer system, determine the quickest route to send information on a network, find the minimum length of pipes for a housing estate, minimize the amount of time in a manufacturing process, find the shortest distance or time to cover every vertex in a network, and there are many other applications. Prim's algorithm is a set of rules that allows you to find the minimum spanning tree within a network. In the process outlined below, if two or more edges have equal weight, you only choose one of them. It doesn't matter which one you choose. Choose any vertex to start, it doesn't matter. Inspect each edge from this point and choose the one with the lowest weight. You now have two vertices and one edge. Next, inspect the edges starting from the vertices you've got so far. Choose the edge with the lowest weight. You now have three vertices and two edges. Repeat this process until all the vertices are connected, then stop. You have now found a minimum spanning tree for the network. Let's have a look at an example from your textbook. Here we want to find a minimum spanning tree for this network and calculate its length. We'll start at point A. We have a 6, a 5 and a 2, so this is the minimum. So we now have A and B and one edge. Now we look at the others, 8, 6, 5, 6. 5 is the minimum. Now we have three vertices to look at. This one over here is 6, 7, 6, 6, 3, 8. This one here is the shortest. We choose that one. We now have four vertices, 8, 5, 6, 7, 6, and 6 here. So the shortest one is 5. Remember, you've got to check all the vertices you have so far. Right, so we have 2, 6, 7, 6, 6, 8. So this one here is the shortest. And we're done. We've covered each of the vertices in the network. So what's the length of this? Let's add it up. We have 2 plus 5 plus 3 plus 5 plus 2, which gives us a total weight of 17. So your work to practice this is shown here.